What up, yo? The countdown to the exam is on. We're so close. So let's do it. One more free response. 2018, number cinco. So let's hop in. All right. So here we go. That is not the original question. Here we go. So number 5. 2 histograms given right off the bat. Of course, hopefully you've read this already. If not, you should definitely pause this and read this or look in Google Classroom or College Board site, whatever. Just read the question, man. All right, so we got 2 histograms for 2 different schools, high school A and high school B. These histograms are showing us the teaching year, right? So like looking at experience, essentially. If you're curious, I'm over here in this 13 to 16 bin. So, getting old. Next year will be my 14th year, so I've been teaching as long as some of the students have been alive. It's depressing. All right, anyways. So important to note, teaching years recorded as an integer, right? So when we look at this bin, right? This bin is only years 1, 2, and 3, right? And we know if someone taught for 4 years, that would go in the bin to the right, right? We're not going to look at someone who taught 1.5 years. Both sets have a mean of 8.2. 200 teachers at high school A. So over here, our N is 200. 221 teachers at high school B. And this tells us what I mentioned earlier. Each interval represents possible integer values from the left, but not including the right. Meaning if someone had 4 years of experience, they're not in the bin to the left, they'd be in the 4 to 7 in the bin to the right, which is generally true for all histograms. So we've got 3 parts here. Part A is going to give us 2 medians. One of the schools has a median of 6. One of the schools has a median of 7. We have to determine which school has the median of 6, which is the 7, and explain how we know. Part B is going to ask some information about the means. We have the average for 200. Whoops, sorry, for our sample, right? Whatever, of 8.2. We're going to be given some additional information, and then part C is gonna tie in some other stuff. We might as well just wait till we get to it, right? What am I doing? All right, so part A. Part A, as I mentioned, so the median teaching year for one high school was 6, and the median teaching year for the other high school is 7. Identify which school is each median and justify your answer. So there's a couple ways we could go about this. Most basic way, I suppose, but it's probably, the first thing that would come to my mind would be just to understand how to estimate the median of a histogram, right? And so that's what I'm going to do first. So I'm going to hop over to the whiteboard here. You can see I have this pretty heinous looking histogram I sketched. This is for high school A here. And so for school A, remember, we have a sample size. We have a sample size of 200. So I'm just double checking that. I went through and I estimated the frequencies, the heights of each of these bins in the histogram using, right, the one that was given. Obviously, that'd be a little easier to do on paper, but not on my sloppiness here. And if we add these up, let's see, 94, 114, 118, 158, 163, 192, 196. So these do add to 200, all right? So that makes me feel pretty good about my estimates, right? And you might have had one off, a little here or there, not a big deal. So the median, right, is the middle number. The middle data value. The median is if we listed all 200 teachers' years or teaching years in order, right, which one would be in the middle? Right, so to find the middle, what I'm going to do, 200 divided by 2 gives us 100. Now, the median is not actually the 100th data value. So since N is even, we have to look at the 100th and the 101st. And so to think about that, like I tell my students, if you forget that, just think about like if N were 4. Let's say I had 4 data values, 1, 2, 3, 4. If I do 4 divided by 2 to get the middle, I get 2, but the median is not really the second data value. So if N is even, we have to look at between the second and third, right? The median would be the 2.5. Or another strategy, some books, they use for the median, they use this idea of doing n plus 1 over 2. And for this red example I just made up, we would have 4 plus 1 over 2, which gives us 5 over 2. So that would then tell us the median is the 2.5 data value. So this is kind of just memorizing a formula, whatever, it works, right? It's still based on the same logic, right? Two different ways to think about it, whatever, red or blue. Nonetheless, for us, we now know our median is going to be between the 100 and the 101st data value. And so now what we can do is we can start to work left to right, or I suppose we could do right to left, count until we get to that 100th and 101st data values. So from here to here, there's our first 46 data values. From here to here, that's our first 94 data values, right? 46 plus 48 is 94. So if we listed all the teaching years in order, right, the first 94 would be from 1 to 7. And then, right, so this spot takes us up to our 94th data value. And then if we added this, that would take us up to our 118th data value. So if the 94th data value was here, and this were the 118th, the 100th and 101st data values have to be in this bin. So we know for high school A, the median has to be 7, 8, or 9, and the only options are 6 or 7, so we know the median has to be 7. Another way you could think about it, one thing one of my students taught me this year, there's a different way to think about it, right? Starting with the same green, we need to find the 100th and the 101st data value. I'm sorry, between the 100th and 101st, or in other, essentially the 100.5th data value, right, between 100 and 101. So what one of my students did is they just started and subtracted this. Minus 46 gives me 54.5, right? And then minus 48 gives me 6.5. So they start going left to right and subtracting these numbers. And then they know that when they get to a negative, so when I subtract the 24, I end up with a negative difference. They know that's the bin that the median has to fall in. So that's essentially the same logic as us adding up to get to 100 and 101. But maybe for some of us, right, maybe that's an easier way to think about it. So we're going to have to put this into words. But to recap, for high school A, the median has to be 7 because the median's between the 100th and 101st data values. And those data values would fall in the bin from 7 to 10. So we know high school A has the median of 7. All right. Now we got to do the same thing for B. Where did I put B? So here we go. So looking at high school B, the 79 is ruining everything. I can't hold it like that the whole time though. But so we're going to cut this off. Know that this bin over here, the height over this one is 79-ish. So for high school B, right, we're going to do the same thing. Now we know that the median has to be 6 because like that's the only other option. Here we have 221 data values. So same idea. So n equals 221 over 2. That gives me 110.5. So the median is actually the 111th data value. Or again, right, you can look at some stuff, some like this formula for median n plus 1 over 2. That's going to give me 222 over 2, which is 111. Right, and back to this green, that's because if I have an odd number, let's say n equals 3, 1, 2, 3 data values, 3 over 2 is 1.5, but that's not where the median is. The median is actually here, the second data value. Right, so whether you just do the raw n minus 2 like I'm doing in green, same as before, or you do the n plus 1 over 2, whatever, we just have to now understand that the median is going to be the 111th data value. Beauty of the video, if you're like, hey, why'd you erase that so fast? Rewind, the power of the rewind. So we need the median is going to be the 111th data value. From here to here, we have the first 79. So from here to here would take us up to 79 plus 34 is 113. So the 111th data value has to be in this bin, which means the median, I'm going to slide down, which means the median has to be 4, 5, or 6, right? And the only option was 6. Or We do that thing my student taught me, 11 minus the first bin minus 79 gives me 22. And then when I subtract the second bin minus 34, I get a negative, and that's how I know that the median is in this second bin here. All right. So that's one way to do this. Now, that's kind of the easy part because that's just doing the math on paper. But like, we know which median is which now, but now we have to like actually write an explanation. That's the hard part, I would imagine, for most of us. So let's do it. So over here, now we know that high school me, what? High school me? What am I talking about? High school me has a median, what? High school A has a median of 7, and high school B median is 6, right? Answer the question clearly. That's what I was my sentence starter there. So this is because maybe you use some bullets, right? For high school, or for school A, n equals 200. So the median is between the 100th and 101st data value. And, right, I guess I could say, and the 100th and 101st data values would be in the bin from, what was it, 7 to 9. And then for school B, n equals 221. So the median is between, the median is the 111th data value, which falls between teaching years 4 and 7. So that's one way to do it. Now, the other way to do it is looking at the shape. If we look at the shape, hopefully we know that we can draw some conclusions. Quarantine's really doing a number on the hair here. We should be able to deduce some information about the relationship between mean and median based on shape. So for each of these, right, these are both skewed to the right. So for each of these, we should recognize that the mean is going to be larger than the median, right? The median should be where the majority of the data is. Sorry, any measure of center should be where the majority of the data is, but these few values in the tail are going to pull up the average. But generally, we should just know if it's skewed right, means greater than median. So for both of these, the mean of 8.2 is going to be less than the median. I'm sorry, the mean of 8.2 is going to be greater than the median. The mean always gets pulled towards the tail. But which one of these is more drastically skewed? B, right? So since B has a sharper skew, a more drastic skew, there's going to be a bigger difference between the mean and the median for high school B because of that sharper skew. So we could say, since high school B has a more sharply or drastically skewed distribution of teaching years, there's going to be a larger gap between the mean and median than there is for high school A. This means the median for high school B has to be 6 and A is 7, right? Because 6 to 8.2 is a larger gap between mean and median than 7 to 8.2. So that would be a little more of a conceptual way, less procedural way to go about answering this, but also essentially correct. And that's what we'll see here. So essentially correct, states the median 6 for B, 7 for A. We got that. Reasonable explanation, I think we got that. Definition of the median, or applies the definition of a median. So like for this, a lot of that work that I showed on these whiteboards, right, I would imagine would be on your paper on the AP exam. And I think that would help lend itself toward getting the essentially correct here. And then if you look at this, this is talking about the second explanation I just mentioned, looking at the skewness. So 2 ways we could address that. So some good review there. All right, part B, let's do it. So teaching years recorded as an integer, we know that, all that stuff, right? We got both data sets have a mean of 8.2. Sample size of 200 for A, 221 for B. So this says an additional 18 teachers were not included with the data from the 200 teachers at high school A. The mean of the 18 is 2.5. What's the mean for all 218 at high school A? You know, it'd be helpful if I didn't cross out the whole question. So if I jump over to the whiteboard, we know, so we only care about high school A, but at high school A, we know for 200 teachers, the mean is 8.2. And then for another 18 teachers, the mean is, I forgot, the mean is 2.5. Some youngsters up in there. And we need to find what is the overall mean. This is a pretty basic math question, right? We got to be able to get this one right. There's even stuff like this, I think, on some SAT questions that use this idea. Pretty much you can imagine this, like pretend in your calculator, if we were going to put all this in L1, like one theoretical way to do this would be to put 218 numbers in L1. Now, I hope you're not going to do that. Now, we don't know the individual teaching years for all 200 teachers that we have, right, at high school A, but we'll just assume they're all 8.2s. So theoretically, I could put 8.2 in here in my L1 200 times. And then I could throw in 2.5, right? I don't know the individual teaching years for those additional 18 teachers, so my best bet is just to assume they were all 2.5s the average. So then I could put 2.5 in my L1 18 times, right? I could theoretically do that, and that would work. Or if we think about it, to find the average, right, we would just add up all these numbers and divide by the total. So I could add everything up and divide by 218, right? So I could add all 218 numbers and divide by 218. But also, like, I hope you're not going to do that because that would be ridiculous. However, we don't need to do that. We could use some simple arithmetic understanding. Sorry, I dropped my red. Well, adding 8.2 200 times is the same thing as doing 200 times 8.2. Plus, adding 2.5 18 times is the same thing as 2.5 times 18. Sorry, that's sloppy. And that's it, right? That's how we do this. So to read, right, like I'm trying to go through like, where did that come from? For all you formula memorizers out there, I'm not into that. It's not my thing. All right, we're going to take the first, like essentially we're going to take like n1 times x bar 1 plus n2 times x bar 2 all over n1 plus n2. And this would work if you had, right, more than 2 samples. You could do this with 10 samples, right? There would just be like n1 through n10 on the top and x bar 1 through x bar 10 on the top and so on. So for us, we got 200 times 8.2 plus 18 times 2.5 divided by the total sample size 200 plus 18. All right. So that's how we get the overall average. I guess we should like do it, right? So we've got 200 times 8.2 plus 18 times 2.5 all divided by 218. So we get 7.73. So the mean of all 218 teachers is 7.3. We should recognize that the 18 teachers we added, right, the average was lower than 8.2. So by adding those 18 teachers, we were going to pull down the average, right? And that makes sense. This is lower than 8.2. But the original data set with 8.2 had 200 teachers. We're only adding 18. So the 18 are going to pull down the average, but not like an insane amount. And that's what we're seeing here. All right, part C. So part C I like. I mean, I like all the questions. Who am I kidding? But part C I like because it's pretty easy, but it's an example of a question that's easy to overthink. So part C says the standard deviation of teaching year for 221 teachers at B is 7.2. If we pick one teacher at random, what's the probability that the teaching year is within one standard deviation of the mean? So what happens on this question is students oftentimes overthink this. First out, like a lot of my students see probability to think it's going to be super complicated or something. Like it's not. This is simple, so who cares? Don't get stressed about the probability. But what happens to some people is they just get in this like robotic, mindless AP stat mode. And they like maybe use normal CDF, but I'm pretty sure that you would agree that this is not a normal distribution. So the first thing we want to think about is within one standard deviation of the mean of 8.2. What's that mean? Well, if the standard deviation, so the mean is 8.2, standard deviation is 7.2. So within one standard deviation of the mean, 8.2 plus 7.2 is 15.4. 8.2 minus 7.2 is 1. So this question is just asking us, what's the probability that someone taught between 1 and 15.4 years of teaching? But we also know that the teaching years are only recorded in integers, so we really don't care about the 15.4. It's just 15.
They're actually going to be taking it seriously.
So we want to find what's the probability that someone's number of teaching years is between 1 and 15. All right, no big deal. So now we jump back to our histogram here. So from 1 to 15, right? This bin has 1, 2, and 3 in it. This bin has 4, 5, and 6 in it. This bin has 7, 8, and 9. This bin has 10, 11, 12. And this bin has 13, 14, 15. So some students get, or even myself, the first time I looked at this, I was like, wait, but this one ends at 16. But then I remember that there were only integers in here. So 16 would be in the bin to the right. So this bin really stops at 15. So asking what's the probability we're from 1 to 15 years of experience is saying what's the probability we're like between these purple lines. And so now what we want to do is we want to add our frequencies. So this first bin I would say has what, 79 things in it. This is probably 34. This is probably like 28-ish. This is probably 29. And then this is a 19. Sorry for the sloppiness, but to get the total, right, we're just going to add those. So in total, 79 plus 34 plus 22 plus, I'm sorry, I can't read my own handwriting. Let's start over. 79 plus 34 plus, this is the sloppiest 28 ever written. That probably made it worse. Plus this is the worst 29 ever written. And then plus 19 gives us 189. So in red, we know 189 teachers had teaching years from 1 to 15, and that's 189 out of 221. So 189 of the teaching years were between 1 and 15 out of 221 total, and 189 out of 221 is 0.855. And that's it. That's the probability the number of teaching years was within one standard deviation. Oh, I never looked at the scoring for B, but that's because I just know we have the right answer, right? Get the right math and show the work. For C, calculate that we're 1 to 15.4 or 1 to 15. We got that. Correctly sums in the numerator based on the intervals provided, right? So that's adding up all those frequencies from 1 to 15. That's how we just got that 189 in the numerator, right? So we did that. Use 221 as the denominator, got it. And then we do have the correct probability, but notice if you don't have work, you would get partially correct. So jumping back to B, the same thing, oh, it's under here. The same thing would be the case, right? You need work, enough work for how you got that weighted average, right? So show work on the exam. Don't be that person who writes the right answer and doesn't show work because that makes your teachers cry because you know how to do everything, but you get, partially correct because you were lazy or something. All right, that's it. 2015-18, number 5. I'm having a tough time with words and numbers today, but that's okay. I think. I don't know what's happening anymore. All right, everybody. Have a wonderful afternoon.